You talk, sir. Ask me. Hello.
Hello, sir. Can you hear me? Am I audible?
Yes, yes.
Okay, thank you, sir. So, good morning to everyone. Our next speaker, Dr. Kaleem Ahmad, and his research topic is action of non-uniform electric field on neutral matter. Before inviting Dr. Kaleem Ahmad, I would like to introduce briefly. Dr. Kaleem Ahmad is presently working as a head of the Department of Physics, Nizam College, Osmania University. He did his post-graduation and PhD from the Osmania University with specialization in cellular biophysics. Also, he attended national international seminar during his tenure. 3 students have been awarded PhD under him, and the 7 are still working under his guidance, out of which 5 have submitted their thesis. Alongside, he is member of many national and international societies and organizations. To his shelf, he has 50 research papers to edited. Thank you, sir. Welcome to sir. Sir,
Yes,
please
sir.
share your presentation.
Not sir.
Hello. Please share your.
Yes, I'm sharing, sir.
Okay, thank you. Sir, your time is for 30 minutes.
Okay.
Thank you.
Full screen.
ಇನ್ನು ಇದೆ ಮಾಡಿ ಮೇಡಮ್.
Yes. Good afternoon to all. I am Dr. Kaleem Ahmad Jalili from the Department of Physics, Nizam College, Osmania University. At the outset, first I like to thank the organizers for giving me opportunity for presenting my topic, biophysics. Actually, before giving the lecture, it's on the biophysics, in the topic I have given, action of non-uniform electric field on neutral matter, because I am a biophysicist, my specialization. Just only briefly, I've introduced my biophysics unit. It is established in 1971 by Professor P.G. Puranik, sir, the head of the department, Nizam College, then for 17 years, and principal Nizam College. Then afterwards, Professor Gopal Krishna and my supervisor and my Professor Adil Ahmad, sir, they have established this biophysics. It is a huge department. 1971 it is running, and in complete South India, only we are offering this biophysics as a specialization at MSc level. So it is actually, and one of the pioneer in the biophysics is Indian Institute of Science, Professor Manju Bansal. Actually, she was the director then she belongs to biophysics, first batch. I am also 87 to 89 batch from biophysics. I did PhD. Now I'm working as ad hoc. I did now as a regular faculty. Now coming to the straight away the topic, action of non-uniform electric field on neutral matter. Before going to that, what we are studying how the effect will be there on neutral matter when the electric field is applied, particularly non-uniform electric field. So first, the electric field means a region around a charged particle with a force would be exerted on other charged particles or objects. And definitely electric fields are uniform and non-uniform. In the uniform electric field, the field lines, yes. And in the non-uniform electric field, these are the field lines. Now, this behavior of charge and neutral particles in uniform and non-uniform electric field. This you see in the case of uniform electric field. In the case of uniform electric field, you see, if you keep a charge body, which there are two opposite polarities, positive and negative charge, negative. If you place a charge body, it moves towards the opposite charge. Like if you take a positive charge body, it drifts towards the negative. And if you put a neutral body, it will just get merely polarized. The charges are polarized. Case of uniform electric field. Whereas, if you see this figure, a rod and suppose a rod and the slab, if you see example, this produce non-uniform electric field. Here is still the charge body, which has positive charge, it will move towards the negative one. But non-uniform neutral matter, neutral body, it will get polarized, and drift towards the higher field intensity. Gradient is established. It drifts towards the wherever higher field intensity is there. It will get polarized and pulled towards the highest field region. So that is the action, that process, that phenomena also we have learning, that is called dielectrophoresis. And we have the first in the country to establish this technique after Paul established in way back in 1970. And in the whole country, our group, the first group who has established this dielectrophoresis technique. This will come here also after this slide. It's very important. So because the drift towards the higher field intensity, from that the gradient is established and the particle moves. Now, to produce this non-uniform electric fields, there are different configurations. Pin-pin electrode configuration, wire-wire electrode configuration, isomotive field geometry, and field construction area geometry. This is the pin-pin electrode, the two pins separated by a certain distance and non-insulating ring is there. That is pin-pin electrode configuration. And next is wire-wire, two wires facing opposite to one another. They will produce wire-wire, that is also called cylindrical field geometry. Then isomotive, it is spread like that, two electrodes, and the spreading will be there. And the last one is field construction area geometry, where two cells are sent through the electrode 1 and electrode 2, and they are subfused. And this is also one of the technique. So the phenomena to produce non-uniform electric field is dielectrophoresis. That's what I have told you earlier. This is the motion of neutral particle caused by polarization effects when subjected to non-uniform electric field. This is the technique. Still, we have improvised, very improvised. We have this setup apparatus is there. High-end apparatus we have I have set up in the laboratory, and definitely my professors have established that. We have improvised. Still, we are working on this phenomena, and definitely it has a unique value at the not only at national level at international level also. So biological cell dielectrophoresis, when you apply to the biological cells, RBC, this will call biological cell dielectrophoresis. And this is the means when you are discussing certain of your technique, the mathematical parameters means when you are, I'm telling that it drift towards the higher field intensity, there is some force. So that is called dielectrophoretic force. Do you want to drive? It is the function of three things: polarizability, alpha, volume of the body, and square of the field gradient. This is very important. Square of the field gradient, because the particle moves toward the higher field intensity, whether you use wire-wire configuration, whether you spin configuration, this gradient is established, and particles are polarized. So polarizability factor also it is important, and volume of the body means the sphere means 4 by 3 pi r cube. Next, like just now for elliptical bodies, their volume is 4 pi ABC by 3, and you see for a sphere 4 pi a cube by 3 because a is equal to b is equal to c, and other uh, same. Next is the polarizability factor for a particular sphere. We are taking 3 epsilon naught k1 k2 minus k1 by k1 p k2. These are the dielectric constant of the medium. Because because we are suspending the particle. We are suspending the particle in the particular chamber. So dielectric constant of the medium, particle also play a major role in this phenomenon. Next. And just now I told you pin configuration. You see delta E configuration is varied with the r to the power of 5 square of the means radius of the electrode. Sorry, distance between the electrode r. And here where it is r to the power of 3. So this factor plays a major role in the dielectrophoretic force expression. This is the phoretic force expression for pin, and this is the dielectric force, paratic force in the case of wire configuration. R to the power of r, the parameters are constant. R1, R2 are the radius. A is the size of the particle. Only the variable, the distance between the two electrodes. But now, when the particles are moving, definitely a viscous drag force is also applicable. It is given by 4 by 3 a cube d1 b v to omega, where d is the density of the medium, micropolar parameter, v is the velocity, omega is the angular velocity. And one more, because it is influence the gravitational force, 4 by 3 a cube d2 minus d1 by g, where density of the medium, density of the cell, and acceleration due to gravity. Now, this phenomena, that is Pearl chain configuration, when the particles are subjected to non-uniform electric field, when you apply the non-uniform electric field, particles earlier they are scattered like this. As soon as you apply it, they will form this Pearl chain, one after the other. This Pearl chain, one after the other, they will form the Pearl chain at the electrode. And that Pearl chain we are measuring through microscope. And now computerized techniques are there. With the help of the computerized technique, we are measuring the length of the chain. You can say length of the chain. So this formation is very important. That is called Pearl chain formation of the cells. Now, that Pearl chain, we are measuring through that one, that is called yield or DCR, dielectrophoretic collection rate, or that is also called yield. Y is equal to 4 pi A6 concentration, and for pin. So this Y, that is also called dielectrophoretic collection rate, DCR. So here in the previous slide, so DCR, when you are suspending the RBC, and please remember, most of the work is on RBCs. We are centrifuge, separated, and put it in the isotonic solution, because it will die if you just simply put it in the still water or some other water. Isotonic solution, glucose glycine solution. That is glucose glycine solution. If you put the RBCs, so they will alive, and that suspension we are putting in the chamber. We are preparing the chamber and putting in the and measuring the length of the chain. This is the main problem here. Actually, we have faced, and scholars, preparation of the chamber. means this is pin electrode configuration. You see two pins, they are separated by non-insulating rings, and these are the electrodes. And here you have to put one drop. Only a drop is sufficient to put, and they will scattered, and you will see the pearl chain formation. So a small drop is needed, and the preparation. This is the preparation of the chamber. The two wires are separated by certain distance, and they are insulated with, means insulated rings are there, and the electrodes are attached, and we have to give to the connection. This is the chamber, pin electrode configuration. These two wires are there, and this is the two electrodes. And here, from here, we have to make the connection. So this is the most, I think, delicate part of the experiment. And for me, I have took almost, to satisfy my professor, they take full satisfaction. I took 1 month for that one, because it is not easy for the other scholars also to prepare this chamber, because a drop is needed just because, and the distance is important. Just now I have told you it varies with r to the power of 5. So this is also is very important, the preparation of the slide, that is chamber. Now, this is the schematic diagram of dielectrophoretic setup. Of course, electrode chamber, oscilloscope, microscope, video camera. We now here and a video camera we have attached it to a computer to get the values like that. Now, this is the schematic figure. This is the pulse generator, means oscillator, and the frequency meter. And there we have given the signals. And this is the setup. You can see here the electrodes are inserted. This is the microscope, and this is the TV monitor. Now we have further attached to the computer, so that within a minute we'll get the reading. Within a minute, time versus DCR. Please remember, means you can ask me, means how, means other parameters are kept constant. Other parameters means frequency, 1 megahertz. Why we are choosing 1? Because the biological cells, means 1 megahertz to 10 megahertz, will get that Maxwell-Wagner type of polarizations. In that only we will get the information of the biological cells. And 40 VRMS, that is fixed. Below also it is varied, but generally above 40 to 50 VRMS will keep the voltage. So voltage is fixed. Voltage is fixed. Frequency is fixed. And this is the and this is the stopwatch, and all these are the connections, and we are attached to this TV monitor, and that is the graduated one. Clear, that is a graduated one to measure the length of the chain. Will be a graduated one, so that it will be along the axis we have to measure. Along the axis we have to measure. Now you see, when no field is applied, if you put a drop of suspension into this, this electrode chamber, a drop you have to suspend. All other parameters should be constant. Concentration of the cells, frequency, voltage, and here variable is time versus DCR. Half minute, 1 minute, 1.5 minutes, 2 minutes, either the way. But other one is by varying frequency also. 1 megahertz, 1.5 megahertz, 2 megahertz, 3. That also can be done. So the scholars have done, and I too have done that one. So no, this is the same. When no field is applied, just you put a drop when you do one drop, if you take, particles are slightly scattered in the means if you see in the microscope, it just scattered, just they are wandering when no field is applied. No field is applied means that external field 40 VRMS and frequency is fixed. After the application of the field, you see this behavior. They are attached in the form of pearl chain, one after the other, but we are concentrating along the axis. Along the axis. So this part is graduated one. Graduated one in the scale means you can say 1 micron is equal to, in the terms of microns, the divisions are made. So we'll make that divisions and put it, convert it into the centimeters, and the readings can be taken. And from the knowledge of excess DCR, excess permittivity also can be calculated. This is electrical parameter.
Sir,
Giving this different values.
Kaleem sir,
Yes.
please complete in 2 minutes. Your time is over.
Yes, sir.
Sir, please complete in 2 minutes. Your time is over.
Okay. Now just so this is the technique. This is the dielectrophoretic electrical status of the cell. Parameter excess permittivity is considered, and the particle taken permittivity of the suspending medium and the particle. And here we are measuring the DCR and dielectrophoretic velocity or balanced voltage also. And now, just I want to applied aspects, I want to tell briefly, because from that technique, we can separate from normal to disease cells. Suppose a person is suffering from malaria. So this values of DCR comes to be low compared to the here normal. Normal will get around 80 microns, 80 to 90 microns DCR. But in the case of malaria, it will be 40. In case of diabetes, also 40. But in case of patients suffering from anemia, the values will be 120, 130. So this is the method we can, up to certain extent, we can identify. Like I will not say identify the disease. Up to certain extent, we can say that some abnormality is there in the sample, because supportive parameters also there, hematological parameters like RBC count, WBC count, hemoglobin content. If you attach to biochemistry or other labs, we can say that the person is suffering from this disease. But from our study, we can say that some abnormality will be there in the sample. So this is a unique technique, and we have been doing, and many scholars, still 1 or 2 scholars are improvising this and going to the different extent. So that recently also one of my scholars has submitted is working in Manu as a contact basis Yaur Rahman on the flood of aerial and terrestrial animals species, and he has submitted in this one. So this is the brief introduction of my technique. I really thank the organizers, particularly Professor Aleem Basha Sahab and Dr. Priya Madam and other members of the team, and giving me the opportunity to present my paper and activity whatever there in the biophysics lab Nizam College. Thank you one and all.
Thank you, sir, for your remarkable lecture. Any question from audience?
Professor Najam sir also, sir. Really, I thank you, sir. In interaction with you many times. So, any questions are there? I'm ready to.
Hello, good afternoon, sir. It was really nice to hear from you, sir. Hello, good afternoon, sir. Am I audible,
No, sir. Hello.
sir? Hello, good afternoon, sir.
Good afternoon, sir.
Am I audible?
Yes, sir.
I have this question regarding your basic slides, sir. You talked about a neutral molecule, and then in your fourth statement, depend upon the polarizability of the material.
Disturbance is there.
हमारा वो टेक्निकल सेशन कांग्रेस का कांग्रेस
Yes, sir.
उर्दू साइंस 17 पेपर आए बोले मैं भी लिखा लेकिन पक्का नहीं हुआ पूरा आदिल को बोलूं प्रेजेंट कर लो डाल दिया लास्ट टाइम
Hello?
Hello, sir.
Hello, am I audible, sir?
Yes, sir.
My question is that in the fourth equation, in your beginning slides, your full was depending upon the polarizability of the material.
Yes, sir.
So, since the particle which you are using is a neutral particle, polarizability of the whole material or what you are considering here?
I didn't get you, sir, because it's not audible. Means
So,
depends on the polarizability. Because why? Because just neutral matter particle will get just simply polarized.
okay.
But when you apply the non-uniform electric field, definitely it will get polarized, but it will drift towards the higher field gradient. So here the important parameter is field gradient is established.
Okay.
Field gradient is established. Velocity gradient is there from upper to lower. Here also electric field gradient is established for pulling the cells towards the higher field.
Okay. Then,
Concept in our technique.
okay. So then, since your topic is on a neutral particle.
Yes, sir. So means we are considering because of definitely RBC also is a negative, but we are putting in the isotonic solution. So making it neutral, and we are studying.
Okay. Well, once again, in RBC you have hemoglobin which contains iron also. So how you do separate that iron from the hemoglobin?
See, we are centrifuging at the rate of 1500 RPM, and with a minute technique, we are just a point drop we are taking from that one. It may be there, but effect will not be there. Only overall, how it is, we are putting in the suspending medium, how is interacting, we are observing that phenomenon.
Actually, you are using the same in the pin electronic configuration also in your technique where you used RBC, drop of RBC there also. So it's
Yes.
not, since it is a RBC, so it may have some minute concentration of
Yes.
hemoglobin, which is like iron.
And if
It's
we
a
get the
ferromanganese.
supportive biochemical investigation, like just now I told you,
Okay.
that WBC count, RBC count, platelet count, all supportive, so that we can correlate and we can extend it to different intensity. I have attached this our work to MESCO Diagnostic Center. They have helped us out, but it depends on the how far the technique will be very much useful for the in case of the person who is involved in medicine.
How you make assure that the uniformity of the substance? This last question only.
Pardon,
How
sir?
do you assure when you are putting your the pin electronic configuration on your microscope where you are constructing your design? So how you make sure that there is a uniformity of the material? Thank you, sir.
Sir, I didn't get means how you are patient regarding patient. Hello.
Yes, sir. Thank you, sir. Now I would like to call Ms. Juveria for vote of thanks of Dr. Kaleem Ahmad.
Assalamu alaikum. On behalf of the organizing committee and participants, I extend my heartfelt gratitude to Dr. Kaleem Ahmad Jalili for your enlightening talk on the topic action of non-uniform electric field on neutral matter. Your expertise and insightful contributions have enriched our discussions and elevated the quality of our conference. Thank you, and thanks everyone.
Thank you, Juveria. Thank you, Kaleem, sir.
Thank you, sir.
Now our next session is paper presentation. So I would like to request all the presenters kindly join the link. Miss Juveria.
Assalamu alaikum. A very warm good afternoon to chair, co-chair, and the wonderful audience present here. I am Juveria Iram, PhD scholar in physics section, Maulana Azad National Urdu University. Uh, uh, my supervisor is Professor Basha. Today I am thrilled to present my work in our own department symposium, Current Advances in Applied Physics 2024. So let's begin with the title of my topic. So this is the title of my work, Axial Thickness Measurement by Terahertz Wave, a non-invasive approach. And we use the laboratory of Anil Kumar Sen. Yes, and we are very grateful to sir for providing us the laboratory facility. Nice. Next. So, introduction. Yes. This is the abstract of introduction. Avian eggshells are multifunctional structures. It provides mechanical support and protect the embryo and regulate gas exchange. Understanding eggshell property is crucial for reproductive biology and egg quality assessment. Traditional methods limit sample sizes and hinder longitudinal studies. So our aim is to develop a non-destructive approach for accurate eggshell thickness estimation. The significance of the study. The significance of measuring eggshell thickness using terahertz waves lies in its ability to provide rapid, non-destructive, and a precise assessment of egg quality, leading to improved efficiency, early defect detection, and enhanced product integrity. It is very useful in egg industry. Materials and methods. We have taken 6 brown table eggs and 6 fertile eggs. Table eggs are infertile eggs usually, and they are served on a table, so we call it table eggs. And the technique that we are using, time domain terahertz spectroscopy, the eggs were irradiated, reflected, and analyzed using a window function, especially for designed for this. Interference signals from the eggshell membrane boundary and outer eggshells were obtained. And frequency domain analysis for eggshell thickness was done. Cool. This is the setup in Accra. Um, no, sir, I was just showing the setup. Sir has already shown this thing, the setup. It is made in Germany and it's the model name is Topsica Terra Flash. Results: our non-destructive approach successfully estimated action, thickness, and providing a valuable tool for research and conservationists. The prediction model demonstrated high accuracy when compared to traditional destructive methods. Here is the formula that we are using for thickness, and the one peak that is done. So we have two peaks and we are taking the time delay and we are calculating the thickness, delta T that we are taking. Now here is the spectrums that we are getting. These are for fertile eggs and infertile eggs. So we have calculated this thickness for different eggs. It is between 0.3 to 0.4 mm. Conclusion: terahertz reflectance spectroscopy offers a promising avenue for studying eggshell properties without damaging the eggs, and further research can explore its application across different avian species and eggshell variations. These are some references. Thank you. Is there any questions?
Any question from audience? Online or offline? बोलिए बताइए।
वो एक एक्सेल इंटरफेस सरफेस से है और एक बीनीथ जो उसके एक्सेल के बीनीथ जो मेम्ब्रेन है वो वहां से एक है रिफ्लेक्ट हो रहा है।
ठीक है हमारा सैंपल भी रेफरेंस पे तो सैंपल भी का क्या है बड़ा पीक का
ये सरफेस से आ रही है और ये
बताओ जाके
ये सरफेस से आ रहा है वो
वहाँ बताओ ना जाके आई थिंक रेफरेंस डेल्टा टी
This is time delay delta T and C is the speed of light. Second sector and two number
टू
two class है.
थैंक यू वेरी मच
Sir has some questions.
ठीक है खलील सर।
Sir, we have calculated for a PGN egg also. I have not included that in this presentation. Yes, sir. Yes, sir.
He is saying
That's why I'm saying, sir. That's why I'm saying that we have taken the measurement of pigeon eggs also, and it is 0.18. So, sir, we have not checked other eggs. We have only checked for chicken.
for any other sample. His topic.
Yes, right.
Thickness, sir.
I did not found any such paper when I was reviewing, so I have no idea about that. And sir has already explained in the morning that.
Thank you खलील सर। ठीक है, thank you very much.
What is the time? Picosecond.
Yes.
So what is the gap between two peaks? Approximately 5 picosecond.
देख लो ना 5 picosecond वो लिखा है।
So you can bring near to 1.11 picosecond. So that thickness you can measure.
Approximate picosecond, sir. Approximate, sir. You can measure the picosecond. Yes, sir. Yes, sir.
Time you are measuring. You can compress it. It's a very there. Between the length.
You can measure picometer, sir. Yes. Thank you very much.
Answer is also there.
So our next speaker is Mr. Sultan. Yes, sir. Online है sir सारे। So our next speaker is Mr. Sultan. His presentation topic is synthesis, linear and third order nonlinear optical properties of donor pi acceptor, pi donor chromophore for analog applications. So Mr. Sultan, kindly share your PPT and present within the 10 minutes.
Yes, sir. Yes, sir.
Hello, Mr. Sultan.
Yes, sir.
Can you hear me?
Yes, sir.
Please share
My
your.
screen visible, sir? Sir, my screen is visible.
Please share your PPT. Video on.
Yes, sir. Sir, my screen is visible.
Please.
Hello.
Mr.
Yes, sir.
Please 1 minute.
Sir, my screen is visible too.
1 minute.
But not with slide sharing mode.
Please share your PPT in slide sharing mode.
Yes, sir. It's okay. Yes, sir. Hello.
Please.
No, it's not yet on slide sharing. Slide sharing.
अभी नहीं है।
Maybe it's not done slide sharing.
स्लाइड शेयरिंग मोड पर करिए। शेयर कीजिए, उसके बाद दोबारा से शेयर करो। Kindly share your PPT again.
Yes, sir. Is visible?
Yes,
Now
yes,
go
yes.
on
Now
slide
is
sharing mode.
Yes, sir.
hello. Please share your PPT in slide sharing mode.
F5, go to F5.
F5. Press the F5. ये
Yes, sir. It's
तो कब
on.
दिखाई दे रहा कब ये नीचे नीचे बॉटम पर ये
F5 go to
F5 press the F5
ऊपर go to slide share.
स्लाइड शो
ठीक है वो तो
ठीक है स्टार्ट करो
Okay, sir.
ओके
Yes, sir. My name is Sultan. I'm research scholar, Department of Physics, Aligarh Muslim University. And my topic of presentation, thesis, synthesis, linear and third order nonlinear optical properties of donor pi, acceptor pi, and donor chromophore for analog studies, analog applications. Sorry. This is the outline of my presentation. First of all, I will discuss introduction of linear and nonlinear optics, and then motivation of my motivation behind this work, and application of nonlinear optics, and then material and synthesis, FTR, NMR, and analog study, and finally I will conclude my presentation in the end. Optics is basically is a branch of physics in which we study the behavior and its property of light, including light matter interaction. And on the basis of intensity, optics is divided into two parts: linear optics and nonlinear optics. And linear optics is also called the optics of weak field. In linear optics, the optical properties are independent of light intensity because the interatomic field is greater than the light intensity. Then the optical property is independent of light intensity, and frequency is unchanged as passes through the non-linear optical linear optical material. And in case of linear optics, the induced polarization is given by this expression, and this graph shows the variation of polarization with electric field, because the polarization directly proportional to, so graph is linear. This I have shown some linear phenomena which is uh, which is depends on wavelength but not on intensity, like refraction, scattering, and dispersion. Nonlinear op- uh, Nonlinear optics. Nonlinear optics is also called the optics of intense light. If the incident light intensity is greater than the interatomic field, then the optical properties are depends on light intensity. And in case of nonlinear optics, the frequency can be changed as passing through the nonlinear optical material. And in case of nonlinear optics, the induced polarization is given by this expression, where chi1, chi2, and chi3 is the first order, second, and third order nonlinear susceptibility. And this graph shows the variation of polarization with electric field at low intensity. The polarization vary linearly, but at higher intensity, the polarization vary in nonlinear way. I have shown some nonlinear optical phenomena, which is divided into two parts: kite 2 and kite 3 effect. And I have shown four phenomena in kite 2 effect, like some frequency generation, some frequency generation, second harmonic generation, difference frequency generation, and optical parametric amplification or oscillation. In Chi3 effect, I have shown also four phenomena: Kerr effect, optical Kerr effect, third frequency generation, XPM, self phase modulation, cross phase modulation, and self focusing or defocusing. My motivation behind this work is there is a has a demand for nonlinear optical material with large third order nonlinearity for applications such as optical limiting, optical switching, optoelectronic devices, and various varieties of optical material like organic dyes, chromophores, organic single crystal dye, doped polymer, semi-organic metal complexes, semiconductor liquid crystal, and gold nanoparticles have been designed and reported for in the recent past for the third order nonlinear study. Actually, I am working on the organic chromophore because there is has been no lot of advantage over the inorganic one due to large large optical nonlinearity, ultra fast response time, low cost, easy structure tailoring, and easy device fabrication. These are the some application of nonlinear optical materials like in optical data storage, optical computing, optical switching, frequency generation, laser protection equipment, and optical communication. I have synthesized uh, uh, donor extractor type molecule. In this molecule, this group act as a accept donor type, and this moiety act as a acceptor type. So our molecule donor pi acceptor pi donor type molecule, which is the essential condition for the uh, nonlinear active material. So these are some reported molecule for measuring the linear optical material. We have recorded the linear for measuring the linear optical property. We recorded the absorption and emission spectra in the ethanol solvent, and we found two absorption peak at 242 and 342, and due to pi to pi or n to pi transition, and we calculated the optical band gap using Tox relation, and we found the optical band gap of our molecule is 3.2 electron volt, and we have calculated the linear absorption coefficient and extinction coefficient using, and also refractive index and optical conductivity percentage transmitter and reflectant with using these equations. And you can see the all linear optical property depends on wavelength, and I have shown this optical properties, variation of this optical properties with wavelength in this figure. And and I have also calculate the uh, linear optical property at wavelength 522 nanometer, which is used in fitting of uh, calculating the nonlinear optical property. This is used. This value is used for calculating the nonlinear optical property. FTR study, we have recorded the for structural confirmation. We record the FTR spectra of our molecule, and we found in the range of 400 to 4,000 centimeter inverse, and we found the OH stretching at 300, 3320 centimeter inverse, and CH is stretching 3015, and CH stretching for due to aromatic ring, CH is 2930, and C triple one is stretching at 2210, and CC is stretching 1650, and CC is stretching due to ring at 1580, and COC is stretching at 1342. And we found various absorption peak and below the 30 centimeter inverse due to different type of bending, different type of deformation like bending, scissoring, rocking, twisting, and wagging. And for measuring the nonlinear optical property, we record the close aperture Z scan transmittance at various concentration and power. And theoretical fitting is given by this equation where x equals to z by z, or z is the position of the sample and z are the relay length, and rho is equal to delta psi over delta phi. Delta psi is the nonlinear phase shift due to the nonlinear reflection, and delta psi is phase shift due to the nonlinear absorption. And L effective is the effective length of the sample, which is given by this relation. And for calculating the nonlinear absorption, we record the close open aperture Z scan transmittance at various concentration and power, and we found the valley configuration in open aperture. So our molecule saw reverse saturable absorption, and this and this in theoretical fitting is given by this relation where and also calculate we have also calculated the third order nonlinear susceptibility, whose real part related to the nonlinear absorption, nonlinear refraction, and imaginary part related to nonlinear absorption. We have also calculated the hyperpolarizability using this relation manually. And optical limiting, because our molecules saw our molecule show reverse saturable absorption. So our molecule can, sorry. These are the finding of these are the nonlinear optical parameters at various concentration, and power. In this table, I have compared the nonlinear optical parameters of some reported molecule M1, M2, and M3 at yes. In this table, I have shown the variation of N2 and beta with the concentration, and in this slide, in this graph, I have shown the variation of N2 beta with laser intensity, and both value, absolute value of N2 and beta, absolute value of linear an increase almost linearly with increase the solution concentration and laser intensity, and beta increases linearly with input laser power. So analog in the form of the RSA is the consequence of direct multiphoton absorption as a steady state assisted photon absorption. And conclusion. Sorry. Optical limiting steady, because our molecule shows the our molecule shows the reverse saturable absorption. So this molecule can be used as an optical limiting application. So I have studied the optical limiting study of our molecule, and the optical limiting study basically the shows the transmittance decreases with increases the input intensity, and this graph shows the value of variation of threshold input intensity and saturated intensity with concentration.
Please go to conclusion slide.
Conclusion: linear optical properties are independent of light intensity, but nonlinear optical properties are dependent. And this technique is used to measure the third order nonlinear optical properties, and this technique is highly sensitive. Third order nonlinear optics, mostly the nonlinear absorption and nonlinear refraction are measured. Third order nonlinear optical properties are used in optical computing, optical switching, optical data storage, etc. And optical organic chromophore has been synthesized successfully using the condensation method. The linear optical property of the organic chromophore has been examined by the absorption and emission spectroscopic analysis. And third order optical nonlinearity of a chromophore has been examined using this technique, employing the CW laser diode laser at 520 nanometer. Sorry. Thank you.
Thank you, Sultan. Chaudhary sir. Bye.
Yes, sir.
What is the order of what is the third order knowledge? How do you measure?
Yes, sir. Please. Hello.
Hello. Sultan, value of chi 3.
Yes. Value of chi 3.
How much order?
10 to the power minus 6 ESU.
Minus 6 ESU. 6.
ESU.
For what type of laser? Continuous or pulse laser?
CW laser. Continuous wave. Yes.
Experiment was a open aperture experiment or closed aperture?
Actually, sir,
yes.
In both close and open aperture. Yes.
Okay. But I think value is looking very high. It should be lower.
Actually, sir, he measured
it. Should be order of minus 18 or something. 16. Minus 6 is I think.
Hello.
Hello, Sultan. Sir is saying the value
is looking very, very high. It should not be then second order. Because this like repeat what second order. Third order value is always order of 24.
Hello. Sir, yes,
Hello.
I'm not hearing clearly.
Okay, no problem. Thank you.
Okay. One more question. Sultan,
Yes.
you measured the thermoidal nonlinearity of donor acceptor donor type chromophore.
Yes.
What is the responsible for this? To measure the thermoidal nonlinearity in these molecules. What type of responsible for this response in your organ chromophore?
Yes, for responsible parameter for nonlinear optical properties is wavelength of the radiation and intensity of the radiation and
No, I am
concentration
saying
of.
that you measure the thermoidal nonlinearity of donor acceptor donor type organic chromophore. Why you
Yes.
choose donor acceptor donor type organic chromophore? What is the property of these molecules which is responsible for analog response?
Intermolecular charge transfer should be transfer for showing analog property of any type of molecule. So donor acceptor type molecule show more intermolecular charge transfer. That's why I select this molecule.
Okay. Thank you, Sultan. Thank you. So our next speaker is Aftab Alam, and his presentation topic is predicting energy level for electronic configuration 4p24d and 4s2 6 of 5 times ionized krypton Kr6. मिस्टर आफ्ताब आलम काइंडली शेयर मैडम ये मिस्टर रईस के उससे शेयर कराऊंगा, रईस के साथ शेयर कराऊंगा। आफ्ताब आलम, कैन यू हियर मी? रईस के नाम से देखिए। तो नेक्स्ट स्पीकर इज आबिद अली। आबिद अली, आफ्ताब आलम, मोहम्मद रईस, एस सौंदर्या, सौंदर्या, please share your screen.
Yes, sure, sir.
Kindly share your presentation.
So is it visible, sir?
Yes. The presentation topic of Ms. Soundarya: review on influence of copper in bismuth-based oxychalconite materials for thermoelectric applications.
So am I
Kindly
audible to
complete
you?
your yes. Kindly
Okay,
complete
sir.
your PPT in 10 minutes.
Yes, sure, sir. Good morning, everyone. Myself is Soundarya, and I am a MSc Chemistry student at PSG Krishnamal College for Women, Coimbatore, Tamil Nadu. Today, I am here to talk about review on influence of copper in bismuth-based oxychalconite materials for thermoelectric applications. Overview of this presentation. What is the need of thermoelectric devices? Why are we approaching it? What is its objective? How it will benefit to the society? What are the drawbacks of previously used thermoelectric materials? How we are overcoming those drawbacks through oxychalconite materials. Number 5, scope of the review, followed by review of literature and conclusion. What is the need of thermoelectric devices? Energy crisis, a main problem. A multifaceted energy crisis looms. Population growth, pollution, and waste heated strained resources, while constant power demands stretch your infrastructure. So this leads to declining the efficiency in electronics. So thankfully, our renewable energy is gaining attraction with energy scavengers emerging as a promising trend. So what will be the solution is absolutely thermoelectric applications. Objective, How it will benefit to the society? The solution will be the thermoelectric applications. These innovative technologies convert waste heat into usable electricity, offering a sustainable and efficient path to address the energy crisis and power our future. The following images are the thermoelectric generators and thermoelectric coolers acting as a thermoelectric devices for energy harvesting applications. Material of choice for thermoelectricity. Here, this table compares three material types: metals, insulators, and semiconductors. It shows that metals have high electrical conductivity and low Seebeck coefficient, while insulators have the opposite properties: low electrical conductivity and high Seebeck coefficient. Finally, the semiconductors are shown to have the moderate electrical conductivity and Seebeck coefficient, making them the most suitable materials for thermoelectricity. In summary, this image highlights the key material properties that emphasize that semiconductors are the most suitable material type for the balance of electrical and thermal conductivity. So, absolutely, semiconductors act as a good thermoelectric material for thermoelectric applications. This thermoelectric application is based on three types of methods: Seebeck effect, Peltier effect, and Thomson effect. The focus is that Seebeck effect generates the electricity from a temperature difference, where Peltier effect creates the temperature difference from the applied electricity. So while Thomson effect focuses on creating a temperature difference within a single material when both an electric current and a temperature gradient are present. What are the drawbacks of previously used thermoelectric materials? Researchers have explored various materials for thermoelectric applications, but each material comes with its own limitations. So, for an instance, consider tin selenide. It degrades at high temperatures, making it unsuitable for higher temperature applications. While bismuth selenide, even though it is promising, it suffers from directional inconsistencies and in its properties, making device design difficult. Additionally, it is fragile and degrades at high temperature, limiting its use. While comparing lead telluride, although it is efficient, it is expensive due to the high cost of tellurium. So these drawbacks highlights the ongoing challenges of finding the ideal thermoelectric material, motivating the researchers to develop new materials with superior properties. Measurement of thermoelectric efficiency and how we are overcoming those drawbacks through oxide-chalcogenate materials. Measurement of thermoelectric efficiency. The thermoelectric conversion absolutely relies on the Seebeck effect. When a temperature difference is applied across a material, it generates a voltage. So the efficiency of this conversion depends on the material's thermoelectric figure of merit, which considers its electrical conductivity, Seebeck coefficient, and thermal conductivity, where ZT is equal to S square sigma divided by Ke plus Kl into T, where S square sigma is called as the power factor. So how we are overcoming these drawbacks through oxide-chalcogenate materials? Here, the following key points in this slide addresses the advantages of oxide-chalcogenate materials that we are going to employ in energy harvesting applications. Number one, enhanced stability. The oxide-chalcogenate materials exhibit better mechanical and chemical stability compared to tellurides, making them the more durable and suitable for the real-world applications. Number two, tunable conductivity. The presence of oxygen in the chalcogenate materials allows for more control over the electrical conductivity, enabling the achievement of both N-type and P-type conductivity within the same material, which is crucial for efficient thermoelectric devices. Number three, less toxicity. There are free toxic elements like lead, making them a more sustainable and environmentally responsible choice for thermoelectric applications. Number four, potential for higher figure of merit. Some oxychalcogenates have shown promising thermoelectric properties with figure merit values approaching or exceeding those of telluride. So what this summary is that this flyer suggests the oxychalcogenate materials are a promising alternative for telluride materials for thermoelectric applications due to their improved stability, tunable conductivity, and environmental benefits. So what is the scope of this review? This slide shows that oxychalcogenates show great promise for high performance, sustainable thermoelectrics. So continued research on optimizing the performance and stability is crucial for realizing the full potential in clean energy technologies. So this slide material is mainly focused on bismuth oxide chalcogenates as well as bismuth copper oxide chalcogenates compound, highlighting their potential as promising thermoelectric material for energy harvesting techniques. So this review focus summarizes the current state of knowledge in thermoelectric properties, analyzing their advantages and disadvantages, discusses recent research developments and identify the key challenges and future research directions. Crystal structure of bismuth oxide chalcogenates and bismuth copper oxide chalcogenate materials. This slide depicts the crystal structure of two different materials, bismuth oxide chalcogenates and bismuth copper oxide chalcogenate materials. The image displayed here is that the tetragonal crystal structure of bismuth copper oxide chalcogenates and orthorhombic crystal structure of bismuth oxide chalcogenates have the lattice parameters with slight variations depending upon the specific element occupying the chalcogene's position. Number 6, review of literature. This slide delves into the fascinating world of thermoelectric materials, specifically focusing on the bismuth copper oxide chalcogenate family. So by comparing these synthesis techniques, it reveals how each method impacts the conductivity and ultimately the thermoelectric efficiency of these materials. So in terms of conductivity, it showcases how different synthesis techniques influences the conductivity type and conductivity values of bismuth copper oxide chalcogenate materials. So this is crucial because efficient thermoelectric devices require both P-type and N-type materials for effective energy conversion. Number 2, experimental technique. So several synthesis methods are compared, including standard two-step solid state synthesis followed by spark plasma sintering, high pressure methods that utilizes the extreme pressure to manipulate the material structure and potentially enhancing the properties, hydrothermal process, mechanical alloying and sol gel process. Inference. So based on the available data, this slide suggests that the bismuth copper oxide selenide as a promising candidate with the potential for high thermoelectric figure of merit values. However, this potential is highly dependent on the specific synthesis technique employed. So based upon bismuth copper oxide chalcogenates and bismuth oxide chalcogenate type of material, they exhibit various type of conductivity followed by various experimental techniques that is flux method, self-propagating high temperature synthesis, hydrothermal synthesis, and so on. So experimental technique relies on the thermoelectric properties, Z efficiency, and how the inferences are referred. So the chemical analysis of flux method in bismuth copper oxide selenide technique proves that they grow at high temperature that is non-stoichiometric. So these results demonstrate possibility to model the crystal morphology as well as electrical property for their high figure of merit values. So by studying these key ideas, we gain valuable insights into the influence of synthesis techniques on the properties of thermoelectric materials. So this knowledge paves the way for the development of more efficient and sustainable energy conversion technologies in our future. Role of copper in bismuth copper oxide chalcogenates materials. So the strategic introduction of copper atoms plays a crucial role in the materials. So this substitution transforms the simpler N-type materials into desired P-type bismuth copper based oxide chalcogenates. So by mixing the copper's 3D states with the chalcogenate states, the dispersion in the valence band dispersion occurs. Sorry. So by mixing the copper's 3D states with chalcogenates materials, the dispersion in the valence band increases. So furthermore, more research has revealed an unexpected aspect as high crystalline thermoelectric materials with an unusually low lattice thermal conductivity of 0.5 watt per meter per Kelvin, which is usually only seen in amorphous material. So why low thermal conductivity is here? Previously, low thermal conductivity in layered materials was thought to be due to the heavy element like bismuth rattling, but it is not the correct answer. It's because of only the copper's localized mode. It is now theorized that a localized low energy vibrational mode on copper due to weak bonding is the crucial factor. So how this behavior is that they are the incipient ionic behavior. Oxychalcogenates may act as an incipient ionic conductor that the copper has a limited mobility due to the no clear diffusion path. So the copper plays an important role in bismuth-based oxychalcogenate materials for their low thermal conductivity. So what are the implications we observed here is that the alternative design is that these findings offer new ways to design high efficiency thermal materials. Copper's potential is that the unique properties influenced by the copper and open up the numerous possibilities for increasing the electrical conductivity and for the low thermal and for lowering of thermal conductivity to get high figure of merit values.
Soundarya, can you hear me?
Sir?
Can you hear me?
Yes, sir.
Kindly complete your PPT.
Yes, sure, sir.
Within a minute. Okay. Conclude your conclusion.
Sorry, sir.
Conclude your.
Yes, sure, sir.
Complete in 1 minute.
So what is the conclusion we observed here is that the bismuth oxychalcogenates and bismuth copper oxychalcogenates act as a promising material for energy conversion. But we need future research where by unlocking the potential requires for synthesis methods, deeper understanding of doping, studying thin film behavior, exploring nanostructuring possibilities, and by ensuring the mechanical stability and compatibility. So by overcoming these challenges, we can achieve efficient energy conversion and waste heat recovery. I thank Maulana Azad National Urdu University for conducting NSCAAP 2024 and I thank all the co-authors. Thank you. Any questions?
Thank you, Soundarya. Thank you, Soundarya.
Thank you so much, sir.
Any questions? Thank you, thank you.
Yes, sir. Thank you, sir.
So next speaker is Aftab Alam. Hello, Aftab Alam. Madam, Mohammad Rais के नाम से होगा. रईस को मैडम. Aftab Alam. Hello, Aftab Alam. Can you hear me?
I am audible?
Yes. Please share your PPT. ठीक है?
My PPT visible or not?
Yes, but go on slideshow mode.
Please go to slide mode.
Slide mode. My PPT visible in full screen or not?
Yes. Share your.
Good afternoon to all of you. Today's talk is related with the predicted energy levels for the electronic configuration for square 4D and for square 6s of 5' ionized krypton. This work is progress under the supervision of Dr. Syed Jameen Sir Muhammad in the Department of Physics, Aligarh Muslim University. This is my plan of presentation. First, I will briefly discuss about the HF method. This is also known as the central field approximation. And second one is the theoretical calculation of energy levels by the help of Concord. And third one is the level optimization by the computational method LOPT. And final is the result and conclusion. The central field approximation. Basically, it is developed by Hartree in 1928. He assumed that the Z electrons in the atom move independently in a spherical symmetrical net potential. This is called the central field approximation. According to Hartree, the Hamiltonian of an atom is the part of Hamiltonian of kinetic energy and Hamiltonian of electron-electron interaction, and the third one is the interaction Hamiltonian of electron and nucleus, and last one is the Hamiltonian related with the spin orbit interaction. According to Hartree, the wave function of an atom, an ion with an electron is written in the form of the multiplication of the individual wave function of each electron. According to Hartree, in this method, the wave function satisfies the Pauli exclusion principle and are written in the form of Slater determinant. These complicated wave functions are solved in the part of Slater integrals. E average is the chi f k, g k, and r k parameters. Slater parameters f k represent the radial integral. This causes the orientation of L vector and responsible for the separation of terms with different L values and same spin. Quantum number GK is the exchange integral. It is valid for non-equivalent electron. This causes splitting of the with equal L but different total spin. In case of equivalent electron, it get vanishes. Eta represent the spin orbit interaction and as well as magnetic or spin orbit interaction. It is responsible for the fine structure splitting, and RK is the RK represent the interaction integral of configuration to configuration. This is the method of calculation of theoretical calculation of energy levels. Basically, it is known as ab initio calculation or convoluted of electron interval with the no other hypothesis than Coulomb interaction between all electrons and nuclei, which obey Fermi statics and Pauli explosion principle. These calculations are done by the command code on the basis of Hartree-Fock method. Basically, these codes are a Fortran program which consists four code. First one is known as RCN, and second one is known as RCN2, and third one is known as RCG, and last one is known as RCE. This is the some basic information about the RCN code. Basically, it calculates one electron radial wave function for each of any number of specified electron configuration using HF method. And second one command is known as RCN2. It calculates the configuration integration Coulomb integral, electric dipole and electric quadrupole, as well as E1 and E2 transition. E1 and M1 and E2 transition is calculated by the RCG command. And final command is known as RCE. It does a least square fitting of atomic energy levels according to by fitting the Slater parameter and this is the level optimization program known as LOPT. LOPT, it is named LOPT stands for level optimization. The first version of program LOPT was created at NIST in 1995. The latest version, written in Perl language, is given by A. Kremda in 2010. Nature of problem: this problem, by the help of this problem, we can handle, we can find the suitable value of level of why optimization of energy levels. This program consists mainly input file. This is input file contains 3 files. First one is known as parameter file, and second one is known as transition input file, and last one is known as fixed file. And output, after giving the command, we observe output file which produce 2 files. One is known as level file and final is known as line file. The quality of the level optimization is judged by RSS factor, which is known as residual sum of square. Theoretical calculation of krypton 6. The theoretical calculation of krypton 6 is calculated by the help of command code. In this calculation, we perform IN36 file, which is known as input file for command code. We include 117 interacting configuration included for more precise HFR calculation of krypton 6. The Slater parameters: E average is known as average energy, and eta NL is represent the spin orbit interaction. FK and GK, RK are the Coulomb integral, are scaled at 100% and 99% and 85%, 75% and 75% respectively of their HFR value during the ab initio calculations. Energy parameters of odd parity configuration. These are given some energy parameters of configuration 4p, 5p, 4p cube, and 4s, 4p, 4d, 4s, 4p, 5s, and so on. So for this, for the purpose of least square fitting calculation, we link the parameter of interacting configuration. All the zeta parameters linked by the same number as indicated by group 1. And F2 parameter linked by the same number as indicated by group 3, and F2 parameter linked by same number as indicated by group 4, and all other parameters are also linked. By linking the parameter, we can obtain a global fitting of energy parameters. After fitting the parameters, after linking the parameter, we obtain the average deviation of odd parity feed 268 centimeter inverse. This is the energy parameters of even parity configuration. This is shown in table. Yeah.
Please complete your PPT in 2 minutes.
Yeah, okay. The LSF calculation of even parity done by linking the parameter as I already discussed in the previous slide. Is the energy parameters of krypton 6, odd parity and even parity. The highlighted by the blue color represent the it is not fitted well in our calculation because there is a strong mixing of the configuration with other configuration. So this not fitted well. This is the optimized energy levels of krypton 6. We have reported new levels of configuration for level value is 40,000 3518.9. This is supported by 2 line and so on. This is the conclusion. We have reported 19 new levels of configuration for squad 40, which is supported by 43 transition with the help of with the 4p cube configuration, and one level of configuration for squad 6 is reported by us, which is supported by 2 transition with configuration for squad 5p, and one level of configuration for squad 6p is reported by us, which are supported by 2 transition with the configuration for squad 40 and for squad 5s. We have reported total of 47 new lines of krypton 6 spectrum. Thank you.
Thank you, Aftab.
Yep.
One question. Would you tell me, please, what is the basic difference Hartree-Fock and ab initio method?
Basically, Hartree-Fock also calculate the ab initio calculation, but ab initio calculation is the preliminary calculation which is initially predicted by ab initio method. But in the Hartree-Fock method, the level can be the experimental level can be typed in the RC input file, and after that we give some command, and after Hartree-Fock and ab initio is the preliminary calculation, and by the help of ab initio calculation we fitted the calculation which is known as Hartree-Fock calculation.
One more question.
Hello.
Hello.
Can you hear? Aftab? Can you hear to sir?
Yes, I am hearing.
So, have you done any wonderful correction?
Yeah.
Wonderful correction in your potential well?
Have you done any wonderful correction in your potential?
No. Wonderful correction is not done. No, sir.
Potential well.
Hello.
Wonderful corrections you have done?
No, sir. I have not done wonderful correction.
You have not done?
No, sir.
How you got this one now?
I'm not hearing question properly.
Correction, how you can get this one new line? There must be some correction in the potential well.
Sir, I'm not hearing your voice properly.
ओके सर बोल रहे हैं कि आपने जब करेक्शन नहीं किया है तो आप न्यू लाइंस कैसे फाइंड कर सकते हैं? ऑलरेडी लाइंस हैं तो हाउ कैन यू गेट न्यू लाइंस इफ यू डोंट?
This lines has been calculated by the help of transition probability, LSS, cancellation factor, and by the help of also oscillator strength. If the oscillator strength is good, then we can say that this line is observed in our spectrum.
Okay. Thank you, Aftab. So our next speaker is Mohammad Raees, and his presentation topic is DFT, TD-DFT calculation of an organic co-ester of pyrazinamide and p-aminobenzoic acid. Mohammad Rais, please share your PPT and start.
Yes, sir. I will. The slides are visible. Hello.
Mr. Rais, kindly complete your presentation within 10 minutes.
Okay. The slides are visible or not?
Yes, yes. Please go to slide mode. Okay, okay. Thank you. Start.
Okay. Good afternoon. I'm Mohammad Rais. I'm a research scholar in the Department of Physics, Aligarh Muslim University. The topic of my presentation is DFT and TD-DFT calculation of an organic co-crystal of pyrazinamide and p-aminobenzoic acid. This is the outline of my presentation. Firstly, I will briefly introduce about the organic complexes, and further I will explain which methodologies has been used for characterization of the organic complexes, and I will discuss the results from the theoretical calculation, and finally I will conclude my work. In the past few decades, the organic molecular complexes have been synthesized by chemists as well as physicists and biophysicists. In organic molecular complexes, intermolecular hydrogen bonding is an important non-covalent interaction that plays a key role in the crystal formation. And it also improves the physicochemical properties of the complexes. And due to the enhancement of enhancement of the physicochemical properties, organic complexes have shown many applications in pharmaceutical industry, photonics, and optoelectronic devices. Pyrazinamide is an important drug which combines with the other antibacterial drug for preventing the growth of certain bacteria that causes the tuberculosis, and p-aminobenzoic acid is also an organic compound found in several foods. This compound absorbs the UV visual light that can be used in sunscreen, which protect the skin damaged by UV visual radiation. And under the methodology, the UV visual absorption spectroscopy is used to record the UV visual spectrum, and the DFT the density function theory is used for optimization of the molecule, and this optimized geometry is used for the further calculation, including HOMO-LUMO and theoretical NLO parameters. And the time-dependent density functional theory is used to obtain the simulated UV visual spectrum. Here, this is the optimized geometry of the asymmetric unit of the title compound. Here, this is the main interaction part in the asymmetric unit of the complex, and this optimized geometry has been simulated at this theory level V3LYP D3631 plus GDP level of theory, and the theoretical NLO parameter is found that theoretical parameter like dipole moment, mean polarizability, and mean first hyperpolarizability are mentioned here, and the first order hyperpolarizability is found to be 39 times of the urea. So this result shows that the compound have shown this compound has shown high nonlinear response. This is the HOMO-LUMO of the complex. Here, this is the HOMO and this is the LUMO of the complex, and the HOMO is entirely appears on the p-amino benzoic acid, and LUMO entirely appears on the pyrazinamide molecule. In this figure, the charge transfer extended from p-amino benzoic acid to the pyrazinamide upon HOMO to LUMO excitation within the present complex. And the HOMO-LUMO gap is found at 3.62 electron volt from the DFT, and which is close to the 3.29 electron volt which is obtained from the TD-DFT calculation. So this result shows the compound show low kinetic stability and high chemical reactivity. And this is the UV visual spectra of the complex. This blue one is for the UV visual, experimental UV visual spectra, and these are the theoretical UV visual spectra. The red one is obtained in the computed in the solvent phase, and black one in the gaseous phase. The experimental UV visual spectrum has been compared with the theoretical one, and they are found in accordance. There are some shifting found in the experimental and theoretical UV visual spectra. This shifting appeared is due to the solvent effect, and the band appeared at 288.3 nanometer and 273.5 nanometer are assigned for the HOMO to LUMO and HOMO to LUMO plus 1 transition respectively. So finally, I will conclude my work. The optimized geometry of the title compound has been done using the DFT calculation, and the theoretical parameters like dipole moment, mean polarizability, and mean hyperpolarizability are found to be here, and the high value of hyperpolarizability, which is 39 times, suggests that the present complex may be useful in photonics and optoelectronic devices. The HOMO-LUMO gap from the DFT is found close to the from DFT calculation. This low HOMO-LUMO gap shows low kinetic stability and high chemical reactivity. The experimental band in the UV visual of the title compound has been compared with the theoretical, and they are found in the accordance to each other. The band observed at this nanometer, the 288.3 and 273.5 nanometer are assigned to HOMO to LUMO and HOMO to LUMO plus 1 transition respectively. Thank you.
Thank you, Mohammad Rais.
Thank you, sir.
Wonderful talk. So let me one question.
Yes, sir.
Can you tell me, please, what is the effect of tuning the homologue gap on analog properties?
What is the
effect of changing the homologue gap on analog properties? If you change the homologue gap, then
yes,
what will affect on the analog properties?
If the analog gap increase, then the nonlinear response of the compound also increased because the charge transfer of the complex. Hello.
Yes, sir.
The charge transfer from the HOMO to LUMO is a response for the analog properties, analog response.
Okay. Please go to conclude slide. So here you found the homologue gap by DFT 3.62 electron volt and by TD-DFT 3.29 electron volt. Oh, what is how occurs is but the molecule is the same. How it is possible?
It is possible due to in DFT calculation we use an the DFT calculation has been done in gaseous phase, and the TD-DFT calculation has been done in solvent phase. So due to the solvent effect, these differences are found in the calculation.
Sir, any question? Thank you, Rais.
Okay, thank you.
So let me conclude the session. Thank you everyone for your wonderful talk. So I would like to thank every presenter for this presentation in laser and optical physics group. So the next session will be after the lunch break. I request to 2:30. Kindly join online and offline after the 2:30 p.m.